André Xuereb,
Hello.
physics professor at the University of Malta, an entrepreneur. Welcome to this Camilleri Preziosi podcast. It's a pleasure having you here.
Thank you. Thank you for having me. Actually, and it's going to be an interesting conversation, which is a bit out of my comfort zone. So it's going to be interesting.
Of all the conversations that I would have had with you, I mean, this was probably the last one I anticipated about quantum physics. But let's get going. So very often when I attend conferences, webinars, etc., I really notice the great divide that there is between the technical people speak, the technologists, and so the software developers, the engineers, etc., and the legal experts as well. And one of the ideas that we wanted to do with this podcast was to bridge that divide and try to bring together a platform that would bring these conversations together, just to have good conversation and bring to the light new technologies, disruptive technologies, as we're seeing with quantum technologies, AI, etc.
I'll try and keep the techno babble to the minimum. Yeah.
Well, let's try to speak layman's terms today as well. I know that this is quite an exotic subject, so I will try to make it a bit more digestible for everyone out there. But I guess the first question that I'd like to ask you is, I mean, it's physics, but it's quantum physics. What got you here? What led you to this career path?
The randomness of life. So how did it go? I mean, I was always interested in like maths and things like that. So I was always the nerd, basically. And I was always interested in maths and things like that. So I ended up studying for maths and physics here, which was kind of the default option for anyone who liked those subjects but didn't want to become an engineer. Basically, I didn't want to be too useful. So then by chance I ended up doing a PhD in kind of quantum atomic physics in the UK, just because it sounded fun and interesting. It's like there is literally no other explanation. It was fun and interesting, and that was 2007, 2011, which is when the field started taking off. So kind of prior to that, if you talked about quantum computers, it was basically either to get money from people to fund your work or as a joke. And that was about the time it started changing into something reasonable. So it started off me pursuing something just because it sounded fun, but at the same time, that's when the field started turning much more practical, much more interesting, much more technological, rather than just science. And that was basically it. So from that point, I've basically been in the field, and then I came to Malta, ended up being a professor here, and so on and so forth. But yeah, it was basically by chance I ended up in a very interesting field.
Oh, great! So you said that when you started studying the area, it had just taken off.
Pretty much, yeah.
Can we agree that the quantum technologies discussion is now taking center stage amongst the technology community?
I mean, if you just look at the amount of funding, forget about AI, because AI is the outlier. But like if you forget about AI, the amount of funding going into quantum tech by the tech giants, by the governments, programs that we don't know about because kind of there's a lot of defense applications. It is an enormous amount of money, and it's not just the money, but kind of money does breed progress. So yeah, there's a lot going on. It's very interesting. And again, I said this yesterday to someone. 5-10 years ago, if you were doing a physics PhD, then you would go, become a physics professor, or maybe end up in finance. Nowadays, I think more than half are ending up in quantum technology startups. So it's a very interesting kind of change. And yeah, that has bred a lot of innovation. And certainly my world is taken center stage. Maybe I'm not representative of everyone, but it is starting to kind of take over as one of the next big things. Yes, there is AI, but after that? What's going to be the next big thing, or what other things are there in technology? And I think it's one of the most important ones coming
Talked
up.
about areas,
Yeah,
right, in the tech community. And you can also see this from conferences, even locally, where the discussion is also going in that direction as well, from cryptography to encryption to post-quantum, which we will hopefully try to discuss again in layman's terms at some point today. But we mentioned quantum for the audience out there, and me included. What is quantum physics at the very basic level?
The one sentence summary is it's how we understand the universe to work at the small scale, which doesn't answer the question, but I like it because it says nothing and everything at the same time. So it's basically the best way we have to explain how the universe works when we're talking about atoms and small things and delightfully small things. So the idea that if you have a single atom, it can be in two places at the same time, or it can be in two different states, like pointing up and pointing down at the same time. So this idea sounds a bit strange, and it is strange. There is no intuitive way to explain it, at least I don't know of one. And on the surface level, all quantum mechanics is just a set of mathematical constructs that allow us to explain that. But that's kind of the backdrop. Building on top of that, what we're starting to see is that once we've understood how the universe works at that scale, and once we've understood how to manipulate it, then you can start exploiting it technologically. And it's kind of that's the leap which has happened over the past 5-ish years, that we've gone from understanding what the math says and understanding how to control these things in the laboratory just to figure things out, through to controlling them for technologically useful applications. And that's what that was a big spark.
Okay, so the universe works differently at a very tiny scale.
Oh yes, I mean
at very different temperatures.
Temperature is it's a strong way. I mean, temperature ruins everything. So we like things to be cold and kind of isolated.
I see.
Which is probably a metaphor for most physicists anyway. But yes. So when you are talking about small things isolated from each other and so on and so forth, they can be in two places at the same time. Everything becomes very, very weird. Particles. Think about billiard balls, but objects stop behaving like billiard balls and they start behaving like waves. Okay, so they can go in different directions at the same time. They can pass through each other. They can pass through two doors at the same time, things like that. And there's not kind of a metaphoric way of saying it. This is actually what happens. A part of the task of some of my colleagues who don't want anything to do with technology, but they just want to kind of develop the physics, part of the task is to try and understand why the world around us doesn't behave like this. So we still don't understand that. Don't ask me why, we don't know. So there is this kind of break in nature. Small things behave one way, large things behave another way. And yes, as it turns out, we can use or abuse of this behavior to create interesting technologies.
And so let's focus on the technology side now.
Sure.
So how are you embedding, or how is this area embedded, quantum physics embedded within technologies? What kind of use cases are we seeing coming from this idea?
Okay. So not a small question, but let's try and address it. So I mean, there are various ways of kind of slicing and dicing. One of the more popular ones in Europe has, 4 or 5? I keep forgetting. But anyway, there's like a number of different streams of quantum technologies. I can kind of briefly run through them just for kicks, But there's quantum computing. We'll come back to that later, and something called quantum simulation, which is associated with that. Then there's quantum communication, which is kind of next generation way of keeping our communication systems secure. Again, we'll get back to that if we talk about post-quantum. And then there is something called quantum sensing, which doesn't sound very sexy, but it's kind of, again, the next generation way to understand and map out what lies beneath the earth, which is extremely useful for oil and gas, for example, because actually oil and gas, and the example people keep telling me is something like £100 million are wasted in London every year because people don't have a good map of what lies beneath the roads, and they always dig up the wrong place. So if we could find a way to kind of understand what lies beneath better, then that saves £100 million a day. That's kind of one other example. And then there's quantum software, but let's not get into kind of that level of detail as well.
So am I right to say that industries that are mostly concerned with cybersecurity, cryptography, super secure communications, they are the industry that ought to be having a look at these technologies and checking them out?
Yes and no. So let's take a step back. So I said there's quantum computing and then quantum communication. So let's just very briefly kind of run through what the implications are. So quantum computers, they are not like super fast computers. So kind of the narrative in the media usually focuses on a quantum computer is just an extremely fast supercomputer. It is not. There are certain tasks that our computers our present day computers are good at, some tasks at which they're not. There are some tasks at which quantum computers are good at, some tasks at which they're not. And as it so happens, there are some tasks that quantum computers are good at that our ordinary computers are not good at. And some of these are involved with healthcare, for example, designing medicines from the ground up, because to design a medicine, you need to know what the molecule does. To know what the molecule does, you need to predict its structure. To predict the structure, you need quantum mechanics, basically. So kind of quantum computers are uniquely suited for that. There's a whole list of applications when it comes to optimization, which is useful, for example, for optimizing portfolio management in financial services, basically making more money off the stock market, and kind of a whole series of applications kind of gravitating around that set of ideas. And then my personal favorite, which is kind of the negative application, which is quantum computers are known to be uniquely very good at breaking cryptography, breaking the encryption that holds our communication systems secure. And because I'm always asked this question, kind of, how does it work? We're not going to go into the details, but just very briefly, just to give a sense of what's going on. If I gave you a simple mathematical question, like, what is 3 times 13? It might take you a while, but you'll get there. All you need to do is kind of write 13 down 3 times and kind of add them up. Do a few more of those and you'll figure out kind of some tricks and tips and ways to speed it up. So that is not a difficult problem, so to speak. But if I gave you the reverse, which numbers multiply together to give you 51 or 63?
Oh.
It's a much harder problem. The only way to solve that is trial and error. Now, as it turns out, this is what keeps the internet secure. So our ordinary computers, high-performance clusters, whatever, GPUs, are very good at putting numbers together but not breaking them apart. And that's why the internet is secure. And as it turns out, quantum computers have a nice trick up their sleeves and they can efficiently and easily break up large numbers. And that will allow them to basically break into anyone's communication systems. And even if quantum computers are, say, 5-10 years in the future, there is a lot of evidence for what I'm about to say. Certain organizations and countries are stealing data whilst it's going from point A to point B. They steal the data, they cannot break into it because they don't have a quantum computer, but they store it and then wait for 5 years and then break into it. Okay, so it's called store now, decrypt later. And if the data you steal is national security information, healthcare, bank records, 5 years is nothing. So this is something which is actively being exploited by certain actors that know that they will have access to quantum computers in the near future.
So is this the post-quantum conversation that we are hearing about and speak? Is this really a doomsday scenario where all the information is collected and stored now to be decrypted by these technologies at a later stage?
Not all of it is. It is a doomsday scenario, in my opinion. It's a big threat. It's, from a point of view of kind of Western democracy, it's probably an existential threat. Not all of our information will be collected and decrypted because I, for one, am not a very interesting person. No one cares about me. But once you start aggregating data, once you start looking at, the data centers that the government of Malta uses, you can easily find where those data centers are, and you can reasonably straightforwardly tap into the pipeline that connects those data centers. At that point, you can make a copy, encrypted, of all the data that the government has. That is extremely useful data. So it's these kinds of pipelines, kind of critical infrastructure and government level communications, which are being copied. Organizations, banks, healthcare, and so on, not individual users. I mean, that would be... It's a bit far-fetched, in my opinion.
And if this is a future scenario that we are envisaging that will potentially happen, is it a future problem that we need to tackle, or is it something that with quantum technologies as they are today, we can start thinking about it now?
No, it is a future problem, but we need to tackle it now, in the sense that, again, the data we're sending today is being stored. That's the assumption we have to make. So we have to do something about it. And this kind of brings us back to what you call the post-quantum discussion. So there is a whole discussion on what's called post-quantum cryptography, and basically that means fix your security algorithms. If you run any kind of organization, any bank, any organization that uses any personal data, please fix your security, your encryption algorithms.
It does cut across quite a few industries, no? Because
everything.
If we take, I don't know, a law firm, as we are, I mean, most of the data is resting on personal data as well. So
everything.
I would say that it does cut across quite a few industries.
No, it does. I mean, some elements are quite straightforward. So some instant messaging apps upgraded to post-quantum fairly, like 1 or 2 years ago already. So at least at the grassroots level, it can be done. But certainly organizations need to fix this ASAP. But kind of that's the surface level. And in reality, post-quantum cryptography, at least as we do it nowadays, it's a good first step, but it's not actually guaranteed to be good in the long term. So there's actually no guarantee saying that quantum computers or some fancy AI-powered algorithm will actually not break post-quantum cryptography. So this is where kind of the quantum guys raise their arms and say, oh, we have another solution. Post-quantum is a very good first step, but one must always complement that, particularly for critical infrastructure, for large organizations, sensitive organizations, and so on, with security at the physical level. Here's where I mentioned quantum communications earlier. So the tech, surprisingly, does actually exist to allow us to create networks, connect organizations, connect buildings, governments, whatnot, in such a way as to make those communication pipelines impervious to at least quantum attacks, but also perhaps other attacks which we don't know about today. So that's kind of the best, the gold standard of future-proofing communication systems.
So wearing the entrepreneurial hat now, what can be done today with technology to cater for this scenario where you have the decryption of mass data and personal data that could potentially happen at a later date?
I mean, again, wearing the entrepreneurial hat, it's an interesting point. No, there are two steps. First, as I said earlier, I mean, organizations need to have a very good understanding of what encryption algorithms are being used, when, how, and for what reason. And anything which is exposed to the outside world needs to be updated. This is not an easy ask. It's not an easy task either. But it's something which needs to be done if you're handling sensitive data. And of course, with DORA and everything else around the corner, things are going to get much worse unless you are compliant. And then kind of again, as an added means to ensure that you really are both compliant and secure, I would suggest, speaking to either someone like my company or someone else who can effectively help map out what your network does and convert the core parts of it, the important parts of it, to onboard quantum security. At that point, you should be able to kind of rest easy, but not before that.
So we're agreeing on one point here, that current technologies do not offer the same standards that quantum technologies will be offering once they are implemented to the industry. Because I can see the industry claiming, we have the right bolts, in place for cyber attacks, cybersecurity, and now, as you mentioned, with all the regulatory safeguards, that there are, that the industry have been thinking about this for quite a long time. So what are quantum technologies going to bring along with them that are going to change the game in this space?
From the attack perspective, as I mentioned, it's just a different way of breaking our systems. So I don't think there's any debate around that. The only debate is whether it's going to be 5 or 10 years or a different number. From the defense perspective, we have a situation where what we've been doing so far has served us okay-ish, but we are facing a new threat for which the new threat that we don't fully understand, and we don't yet know what quantum computers are going to be capable of doing. That is the reality. We have kind of a small understanding of this tiny corner of what they're going to be able to do, but not the entire space. And what that means is we're either going to resign ourselves to playing catch up or cat and mouse, which is very good kind of for some vendors of technologies, because upgrading systems every couple of years is very lucrative, but it costs a lot of money, it's extremely disruptive, and no one is going to keep doing this kind of cat and mouse game. So kind of the added value of looking at quantum tech as a defense strategy is it provides kind of the solution which technically speaking should safeguard you against that entire class of attacks now and in the future. Of course, not everyone has the right use case for it, but again, if you have certain kinds of organizations that are handling certain kinds of data, I would argue then yes, that's important to start looking in that direction.
And you mentioned regulation earlier on, DORA mostly.
Yep.
And we know that the usual suspects, right? DORA, NIS2, these are the regulatory driving forces behind improving resilience digitally within organizations, as well as cyber attacks, or catering for that, those issues. How do you see that quantum technologies are going to factor in within the precincts of these regulations? And how will these technologies assist the industry to comply with the regulatory obligations that are pushed forward by these legislative instruments?
It's a very European question, but yeah, it's a very good point. So if we talk about DORA in particular, but kind of the spirit is the same with NIS2. There's a few other regulations which also encompass critical infrastructure at the member state level, but ultimately they all say the same thing. They all say that kind of once you fall into these categories of organization, some are at member state level, some are at organization level, but once you fall into those categories, then the onus is on you to make sure that your network systems, your information systems, your cybersecurity systems are safeguarding your data and your customers and your organization against pretty much any known threat. And this any known threat is, it's not phrased exactly like that, don't quote me, I don't remember these regulations exactly, but the way they're phrased is extremely general. So they don't, for example, explicitly talk about the quantum threat, but if you speak to the people behind DORA, and we have, I can't remember, there's a certain Peter, whose name I can't remember at the moment, but he's kind of the father of DORA, and we had a conversation about this recently. They're very well aware that DORA doesn't mention post-quantum, but reading between the lines, the only way you can be DORA compliant with the current framework and under knowing that what we know nowadays is to ensure the organization is secure against the quantum threat. Now, that could just be kind of securing it using post-quantum. It could also mean securing it using quantum. Again, there are different circumstances, different scenarios which we need to be looking at. But ultimately, yes, under certain circumstances and for particular industries, going quantum might actually turn out to be the only way to be actually truly compliant with these regulatory domains. Certainly, though, for everyone who falls under them, the post-quantum is a must. It's an absolute must. Otherwise, you will not be compliant.
So it's good for also the legal experts now and the regulators of the countries to start becoming familiar also with these technologies, apart from all the AI aspect that we're seeing taking over, within the industry as well. So that's a lot. To think of when it comes to technologies, right?
A lot that needs to be done, yeah.
There's quite a lot going on right now in the new tech industry. But you mentioned that from a regulatory perspective, this is a very EU kind of dynamic now, mentioning laws and how they integrate with current or future technologies. I guess from a technocrat's point of view, what's your take on innovation versus regulation?
Big question.
Does one complement the other? Does one come before the other? Chicken and the egg situation? What is your idea?
I'm somewhere in the middle. It's good to have a Wild West period, assuming that the Wild West period doesn't end up with people losing their homes or innocent people losing their homes, things like that. So it's always good to have, to allow tech to explore the boundaries. Just like there was a Wild West period in cryptocurrencies where basically everyone was doing their own thing and understanding kind of what can be done, what can't be done, what the limitations are, and so on and so forth.
Yeah, now we have Mika.
Whereas now there's Mika, etc. Yeah. The counterpoint, though, to the people who say it should always be a Wild West, the American big tech in particular, the counterpoint is that at least historically, innovation does emerge from constraints. Necessity is the mother of invention, or whatever we were taught when we were kind of studying English in primary school. But it is true. It is true. I mean, if you are told kind of you have an infinite amount of money and an infinite amount of resources to do X, then you'll find the laziest way to do X. Whereas if you're told you can do X, but only if it doesn't harm that group of people or that, that's going to constrain you to building better systems. Again, case in point, bias in AI. It's an insidious problem. You could either ignore it, which is what big tech is doing, or you can try and figure out how to build AI systems that are explainable. Yeah. And that will lead to further innovation. So, applying, regulation is a very strong word because it can be light touch or it can be kind of, a smothering blanket. So if it's a light touch idea, yes, it will foster innovation. If it's a blanket that smothers everything, then no, it's going to kill everything. And I think this is kind of the issue with the EU. It's not the regulatory aspect per se, is that it tends to kind of converge towards over-regulation or not distinguishing between startups and companies with turnover in the billions or whatever. So I think if the EU kept its regulatory philosophy more or less on track, but developed more light touch frameworks, that could actually help the industry to be more innovative.
I'm not sure if you're aware of the legal conversation that's happening right now, but some drive towards this direction is happening within the EU right now. So there is the omnibus package that has just been rolled out, where there's some speak of sort of watering down some rules in relation to the GDPR and the EU AI Act as well, particularly in relation to small businesses that have been affected by the constraints of the legislation. Not just that, but also from a financial perspective, because compliance is big.
Expensive. It's expensive.
And very financially, a very big financial burden, especially, for these new creators, the startups, the micro organizations that are all coming up with the best ideas first. Yes, where inevitably, the software that they create or the technology that they're creating is going to process personal data or is going to handle a lot of data, where all these heavy, regulatory tools are also, placing their mark. But apart from that, I believe that also we see regulation which gives a platform for experimenting. For instance, you get the
Sandboxes. Yeah, I was going to say
examples where you can test, in a, let's say, Wild West environment, but with constraints, and you also get some perspective from the regulatory authority. So I think that is a great idea, to...
No, it is, and it speaks to this kind of light touch approach. I mean, the omnibus, I was part of those discussions for a bit, at least with some colleagues. I mean, how can you eliminate bias in AI, which is a big problem, without knowing the characteristics that could go into that bias? So as someone who kind of is more of a techie than a kind of a lawyer, it makes sense. I mean, if you hold to the letter of GDPR, it is basically impossible to create systems that are safe enough to comply with the AI Act. It's almost impossible. So it's hard to say it's truly impossible, but it's basically impossible. So yes, there has to be some watering down. Now, of course, the devil is in the detail. Is it going to be a watering down for everyone under every circumstance, or is it a watering down to allow us to get to the right place, technologically speaking? So that's the interpretation. That's where the lawyers come in, I guess. But it's an important realization that regulation is good, but over-regulation stifles. There's a fine line there.
Yeah, and it's always difficult determining that.
It's impossible to find the optimum, I guess, but you can try. Try.
Yeah, as you said, it's a big question to try to answer over here. And, and
no, we're not going to answer that question.
Quite a lot of discussion going on, and I'm sure that will continue to go on in this direction. So before we wrap this up, and thank you for your time dedicated for this podcast, which I hope will be the first one in technology and more to come. I just wanted to ask you, where do you see this area, the area you're involved in, quantum technology, is heading towards in the next few months, possibly, because technology speaks in days as opposed to years. So I can't really ask the question, where do you see yourself in 5 years? But
where I can probably see us going in the next few months is, and it sounds cheap to call it that, but let's use it anyway, kind of more mainstream adoption. So we are in a situation where, because physicists are historically terrible at communicating what they want to do, and because the first physicists who started developing these kind of quantum secure systems acted superior over everyone else, that kind of poisoned the discussion. So for the past few years, there was a bit of a kind of an us versus them scenario with like the traditional cryptographers and the quantum guys on the other side. Now we're starting slowly to realize that the two sides should actually work together. And it's not that they can, but they should actually work together. So, over the next few months, I think this is going to start becoming a bit more mainstream. Also because, at least within the EU, there is the European Commission pushing forward some technologies like the European Quantum Communication Infrastructure, which we didn't mention, but it's basically saying the EU as a whole and every member state should have a quantum secure communication system to use to safeguard its communications. So that's going to start pushing the tech more and more into the mainstream. I mean, quantum computing has become kind of quite mainstream, although there is a bit too much hype in the media, so we have to be a bit careful from that bubble. But yeah, I think like the biggest change over the next, let's say, 6 months to a year is probably the mainstreaming of the discussion, that we're no longer going to be seen as crazy people pushing forward a technology with no use, but actually perhaps slightly less crazy people who have a potential solution to an actual problem.
Thank you.
You're very welcome.
André Xuereb, for your time on this podcast.